Hello everyone, this is Amritpal Singh. Welcome to the next video. In the previous video, I've talked about the neurons. In this video, I'm going to talk about the activation function. So this video will be linked with the previous video. So in case if you haven't watched the previous video, I just want you to please watch the previous video so that you have the basic understanding of all the terms that I'm going to use today, right? Let's get started. So this is the thing we already have discussed in the previous video. We already have talked about the structure of one neuron. So there it is in the middle. We know that it has got some inputs, right? Values coming in. It has got some weights, right? Then it's added up the weighted. It calculates the weighted sum of those inputs. In next step, it applies the activation function. And in step 3, it just passes on the signal to the next neuron. So that's already we discussed in the previous video, right? Till this point, we already discussed in the previous video. So what we have in today's video, we're going to talk about the activation function. What is that, and what are different type of functions available and their use cases. So let's get started. So activation function, if we define like in a basic definition, it applies a nonlinear transformation and decide whether a neuron should be activated or not. That's why it's called activation function. So we can just compare this definition with a simple analogy. In simple words, think of it, it's like a switch that decide whether a neuron should be activated or not. Right, that's why it's called activation function. So whether we have to decide whether a neuron should be activated or not. That's why it's called as an activation function. So if the input is above the certain threshold or meets a certain criteria, the neuron will be activated or fire, or else it remain the inactive. Right, this is how it works. Right, so if it's matching some certain criteria, like I can simply compare it with a simple definition of the trigger in the DBMS subject. Over there we also have a trigger available. If it's matching some criteria, like if we have an update statement or delete, or we can say insert statement, then only trigger will fire, else it remain inactive. So this is called activation. So now the idea of activation function was inspired by the action potential in neuroscience. This is the simple diagram. So what is action potential? It is a certain rise and fall in the membrane voltage or a potential of a neuron in response to stimuli, right? This is so activation function has been inspired from this action potential in neuroscience, right? Just for your knowledge. So now the very first type of function we are having, it's called threshold function. So it's a very simple type of function. You can see in this case we are having this this graph available. So what we have inside in this, so on the x-axis we are having the weighted sum of inputs. On the y-axis we have just the values from 0 to 1. So basically the threshold function is very simple type of function. So what we have inside it, this is a simple we have this conditions available. What it say? If the value is less than 0, then the threshold function passes on 0. If the value is more than 0 or equal to 0, then threshold function passes on 1. Right, so basically it's kind of a yes no type of function, very straightforward, very kind of a rigid type of function, either yes or no other options. So it's very simple type of function we are having, right? Moving further, we are having sigmoid function. The next type of function we are having is sigmoid function. So you can see in this case we are having this equation available. So this represent the activation as a symbol, this one 1 over 1 plus e raised to power minus x. So we have a same graph available, y versus this weighted sum, right? So what is that? The sigmoid function transform the input to the range between 0 and 1, right? So what's the use case of sigmoid function? So it is used in the deep neural networks for binary classification task, where the objective is to classify the output into one of two classes. So this is one of the use case of sigmoid function where we use it, right? So actually if we talk about the sigmoid function, more of it, the advantage, if you can say, the sigmoid function can be interpreted as a probabilistic function that transform the input between 0 and 1. This makes it very useful in the cases where the output needs to predict the likelihood of a specific class. So it's a basic use cases, binary classification task in the case of sigmoid function. The third type of function is very popular these days that we use in the research. It's called rectifier linear unit, or we call it as ReLU, R-E-L-U, right? So in this case, this is a formula that we use in this case, max x comma 0. So this is the function. In this you can see we have this very straightforward graph available, 0 or this. So what it indicates? So ReLU is one of the most popular and commonly used activation function. It outputs the input value if it's positive or returns 0. This is how this graph represent, right? So it says that it outputs the input value if it's positive or returns 0. Basically it is used in the hidden layers of a neural network since it brings sparsity of a data to the data. So what it means? This means that ReLU is able to selectively activate only a subset of neurons and then set all other values to 0. This leads to the more efficient representation of high dimensional data. So this is one of the good advantage we are having. If we talk about more of the advantages, the next advantage we are having is non-linearity. So what it means, ReLU's ability to create sparsity by removing the negative values enhances the neural network's ability to learn complex non-linear patterns and relationship in a data. So it's one of the good advantage we are having, followed by the computationally efficient. Unlike the sigmoid or the first one that we discussed, that so ReLU has a very simple mathematical function, so hence it is very it's quite computationally efficient, providing faster training and inference. So it means, so it has got a lot of positive points. So it has got some advantages over the sigmoid and the first one, the threshold one, right? The next one, the last one in this video, we are having hyperbolic tangent activation function. So what it means, in this case, you can see like we have this equation available, 1 minus e raised to power minus 2x over 1 plus e raised to power minus 2x, the same graph available. So in this case, what's the difference? So the tangent hyperbolic tangent function, it's a type of activation function that transforms the input value between -1 and 0. Earlier we used to have the values ranges from 0 to 1, but in this case we also have a negative part available as well, which is the difference between the previous ones and this one. And it is used in the classification task suitable where the data is symmetric in nature, that is the positive and negative values hold the equal importance. So this is the where we can apply this tangent function, right? I hope from this short little video you must have understood what is activation function in neural networks and what are different types of activation function. So see you next video. Thanks for watching, guys.